Hello, welcome to everybody who's joining this webinar. We can see that there are people who are still joining as we speak, so we're just going to give them another minute or two to log in and get this far. So my name's Jamie Dobson. It's nice to see some of you again. I'm the CEO of Container Solutions and I've been helping out with the introductions to these webinars. Today we're going to be looking at Introduction to Kubernetes with my colleague Martin. Martin is a badass, that's his title, and he specializes in Kubernetes application development, programmable infrastructure. Just a little bit of housekeeping for those who are currently on the webinar. You can ask questions via the questions part of the go-to control panel. You can also download some of your handouts in the handout pane. Anybody who's got questions, please send them our way. There will be a time for questions at the end of the webinar for those who want to wait until then. Okay, so it looks like we've got quite a number of attendees already in, so I don't want to leave everybody hanging. If anybody's having, somebody can confirm to me that they can see our presentation, it should say Introduction to Kubernetes. I'd really appreciate that. While we're checking that, I'm just going to start. I'm just going to start with the webinar. Okay, so welcome back. This is going to be about Kubernetes. Our agenda today is, oh, I've made a mistake in the agenda. Secure microservices with Sam. That should say Introduction to Kubernetes with Martin. My mistake. But I'll just mention a little bit about Container Solutions. I'll mention the announcements about events we've got coming up, and then we'll get straight into the webinar, followed by questions. So about Container Solutions, we're a professional services firm. So we specialize in cloud-native computing. We operate globally, but our offices are mainly in Europe, Berlin, London, Amsterdam. We are opening an office in Canada this year. We're all pretty excited about that. If you need help with containerizations, large-scale distributed systems, we're the people you probably want to speak to. Some announcements. KubeCon London is happening next week. So that's the week of March the 5th, I think. So we're going to be at KubeCon London. We have a booth. We're speaking there. We're running the technical ethics track, and we're also running the developer experience track. So we're pretty proud of being involved in both of these tracks. For many people at Container Solutions, ethics is an important issue. And of course, to many people, so is developer experience and how you use cloud computing to create an optimal developer experience. If you want to reach out to us, you can do so at KubeCon at containersolutions.com. You'll be able to set up meetings with some of our engineers or some of our managers and leaders if those are the type of conversations you'd like to have. In May, we've got KubeCon coming up. So KubeCon will be about Kubernetes and all things associated with Kubernetes. If you're interested in finding out more about Kubernetes, this is really the conference for you. There'll be a combination of talks, of workshops. It's really an excellent community. It's run by the Cloud Native Compute Foundation. It's really a great group of people and very social. So if you can get to Copenhagen, look out for that one. We do have some trainings coming up. Some of them are sold out, so we're sorry about that. But if you want to get more deeply into some of the topics we've been covering in these webinars, just go ahead and click your browser at the trainings page, which is linked there. These links are also available in the handouts. You can use the discount code webinar20. That will get you a full 20% discount off. As I said, unfortunately, a number of these courses are already sold out, so please grab the ones that you need while you can. We only have, in this series, 2 more webinars. The one that you're in now, followed by production grade Kubernetes next week. So production grade Kubernetes will be about much more advanced topics. It's actually filling up. We're close to capacity on that. Paul GoToWebinar sort of struggles with too many concurrent users. So please do sign up if you to avoid disappointment. That's next week. Of course, we're hiring. We're always hiring, looking for great people. The Zurich office really is in the mountains, if you can believe it. Unfortunately, the London office is not in Big Ben. It's in a Mansion House near Bank. But most of our offices, in fact, all of our offices are really in nice cities and in nice locations. We need cloud native engineers, but we also need talented leaders, engineering managers, process owners, and things like this. Front-end developers, marketeers, you name it. So if you're interested in joining a pretty fab company, reach out. These are the career paths for many of the people who work at Container Solutions, and we're pretty good at getting people to where they need to be with their careers. And I think, without further ado, yeah, there's some handouts. I mentioned that already. Grab them down there in the panel. But without any much more messing about from me, I'd now like to hand over to my colleague, Martin, and he's going to be talking about how you get started with Kubernetes.
Well, thanks for the introduction, Jamie. So my name is Maarten Hoogendoorn, and I work in the Amsterdam office of Container Solutions. And the goal of this webinar is to teach you just enough about Kubernetes so that you'll be able to learn quite a bit on your own without getting confused or overwhelmed by all the very high quality content that's available on the internet. In this webinar, I will do 2 things. In the first half, I will explain the architecture and the core concepts of Kubernetes, followed by the other half, which will explain the most used concepts, objects that are in Kubernetes and how to use them. So, Kubernetes. Why would you want to bother with Kubernetes in the first place? So, many companies start out with having just one application, and then they grow another application that's slightly different, and a third one, etc., etc. And all of these applications have slightly different needs on how they need to be packaged, how they need to be deployed, etc. One solution to have a uniform way of deploying them is to put them into containers. And this is happening all over now, and people are now wondering, well, once I have containers, how can I deploy them on-premise or in, let's say, the AWS cloud or the Google Compute cloud? The answer to all of this is Kubernetes. It allows you to move your applications on top of Kubernetes on-premise and then easily transition, for example, to a cloud. I see Kubernetes to be really as something similar to POSIX. POSIX was introduced to standardize the different Unixes that were out there and allowed you to run your one Unix program on a completely different Unix. Kubernetes is much the same, in my opinion. It allows your cloud-native application to run any cloud or on-premise. Now that I've, in my opinion, shown that Kubernetes is an interesting thing to look at, let's take a look at its architecture. So you as a user or a computer program talk to the control plane that is the core of Kubernetes. This control plane then manages and talks to all the nodes that run your actual workloads. So if you want to deploy something on top of Kubernetes, what are you actually deploying? It is not the container itself that you're putting on top of Kubernetes, but you write a manifest that contains a description of what you want to run, but also meta information like limitations of how much memory your container can use, etc. That manifest is sent to the control plane, which stores it in a database. And then it reconciles the existing state of your cluster with the desired state that you as the programmer of the Kubernetes or your deployment script tell Kubernetes to apply. So let's take a look at what controllers exactly are. I like this example a lot to show a physical controller system. This is a robot prototype by Boston Dynamics that are building lots of interesting robots. And the desired state of this robot is to stand on one leg. And as you can see, something bad happens. A ball is being pushed onto it and it reacts to recover itself. Kubernetes is much the same. Kubernetes measures its surroundings, its current state, based on your desired state that we have stored in the database by means of adding manifests to Kubernetes. It creates a plan of what to do, then acts on this plan, which can either be to modify the database so that some other controller can take action on it, or invoke an API call to, let's say, create a cloud load balancer in a cloud, so that stuff actually happens. Sorry. And then this whole system continuously repeats itself to measure again based on the new measurements, the changes that have been happening, like computer just crashed, fine, then Kubernetes will take into account your desired state and plan a recovery plan for that, basically. Now that we have seen the big picture architecture, let's take a more close look at what actually is in there. State is stored in a high available database. It's called etcd. You as a user or computer program will just talk to the API servers. They are stateless and store all the state in this specialized database. Then we have a few different types of controllers. In this case, I've only put the kube scheduler controller on there that will make the scheduling decisions of what workload should run on which worker node. And you also see that the two worker nodes are connected to via the API servers. Now let's do a walkthrough of if you want to put some workloads on top of Kubernetes. Let's run a container on top of it. In Kubernetes, the unit of scheduling is called a pod. And as I said before, you can't directly put a container on top of Kubernetes. You have to write this manifest that describes what you want to run with some extra properties of where and how and etc. This manifest actually refers to the container that you want to run. Once you have written this manifest, you can use the command line utility kubectl or maybe a button in your Jenkins to actually perform a deployment, which under the hood will talk to the same API servers. This kubectl command then will transfer the content of your manifest to the API servers. The API servers will look at what you have done, what you have sent in, and verify that it's correct, and fill in some missing information. In this case, let's say it will update the manifest with a marker that says it's not scheduled yet. The API servers will then store the manifest in the database. We'll get, yeah, it's in the database now, and get a confirmation back that it has been persisted. That means that if some of the database nodes would actually disappear, the database would still be consistent and storing all the data that is relevant for us. The API server gets the confirmation back, which is propagated to the end user, and that's basically the end of story for the first part of deploying something on Kubernetes. What's happening, however, is that the kube scheduler is observing any changes that have been made in the database via a connection through maybe a different API server. So it's notified that there is a new manifest to run a specific container, and based on the information that it has gathered before, it can make a scheduling decision. So the manifest arrives, and based on the information that it has gathered, it then decides to schedule it on node A. Then the scheduler itself doesn't directly talk to node A, but it updates the manifest, sends it to the API server with an update operation, and as you can see now, the data is updated in the database. Then the same pattern happens with node A. Node A observes that a manifest has been scheduled, a pod has been scheduled to run on its machine. And it extracts the data from the manifests, and then, as you remember, we put a reference to the container in the manifest. It exactly starts that specific container. This will give you an overview. I just gave you an overview of how anything in Kubernetes works. You have a manifest, you put it to the API servers, they react to it, and you can query the state later. I was speaking about the pod. That's the basic object that is in Kubernetes. There are a few other objects that I would like to talk about. The first one is the node. The node is a physical machine in your basement or a VM in the cloud on which you can schedule the pods. Inside a pod, you can have one or more containers. And in this example, I'm showing that, let's say, if you have a database like MySQL, you might want to run a program that kills your slow queries and also perform some backups. These are typically side concerns to your main process, and you don't want to run them in exactly the same container, but in sidekick containers. An important thing to remember is that these pods that we are creating are not pets, as we say in the Kubernetes community. They are cattle. And by that, we mean that if a pod dies, we don't really care. It just disappears. No notification happens at all. No one is informed about, you as an end user are not informed about that a specific pod has been gone for a while. We have a high-level concern that takes care of that, called the replica set. A replica set takes a specification of a pod and makes sure that there are an exact number of copies that have the same properties, the same settings. So let's say that if one of the pods crashes, or if one of the servers that we are running workload on top of has a power outage, then Kubernetes detects that it is disappeared, and the replica set will take an action. So the input is, it does a measurement, it sees that it's not exactly as its desired state is, there are only 2 pods instead of 3, and then it will plan and act on that. It will create a new pod and actually start. And afterwards it will clean up. On top of this, we can build deployments. The point with replica sets is that you will deploy exact copies, exact replicas of the same container. This does not allow you to update those containers. So if you want to make a new deployment, the name already suggested, we have to create a new replica set, and you can give the specification to the replica set of a different container, version 2 basically. So the blue one is version 1, the green one is version 2. The default strategy forces you to create one of the new version, and then it will delete one of the old version, etc., until you have slowly migrated to the new version of your program. I've not spoken about how end users can then access the service that you're providing in the service that you deployed with deployments. We use the service abstraction, the service object for that in Kubernetes. Services work by having selectors that are basically a list of labels or slightly different expression that works on labels to make sure that only the pods that are, let's say, blue are actually exposed in this service. So any object in Kubernetes has some metadata, and one of the types of metadata that is associated to it is the labels that it has. And as you can see, we can have multiple services. The green service here selects on the green color, and the this is the way that you can expose different types of services in the end. So this is how it looks like if you put them together. I have a deployment with one version, and the service selects on application foo. Then if I perform a update on my deployment, it will create a new replica set, but I've only changed the version of my container, not the labels that it matches. So this means that I can do zero downtime deployments out of the box by combining a few components that are by default in Kubernetes. Services provide an endpoint to talk to from other, let's say, applications within Kubernetes or external. By default, they get a special IP and a DNS name. So let's say if I start a service called MySQL, then from my PHP application or my Java application, I can just connect to the DNS name MySQL and get redirected to the correct service in the end. Alternatively, a service can also be linked to cloud infrastructure, such as a cloud load balancer. Or the third option is that your service will open on each port on every worker node a specific port that you can then use later on. This is mainly interesting for a bare metal service in basements. In practice, we see that if you are on the cloud, you would mostly use the cloud load balancer types here. The last object I would like to talk about is ingress. Ingress is a bit like a reverse proxy in the traditional sense. So let's say that you have two microservices, one that manages your shopping cart and the other manages your user registration and authentication. We have two users here. The left one is interested in getting some information from his shopping cart, so he should be routed to the microservice of the shopping cart, the cart microservice. And the other one is trying to log in, so he should be redirected internally to the user microservice. Typically, on-premise or even VM-based cloud infrastructure, you would use a reverse proxy such as Nginx. Kubernetes solves this at a different layer of abstraction. It defines an abstract ingress resource that then does the mapping somehow internally. And if you put it together, the whole architecture, you will see that again we build on top of the object that we have defined before already. The actual ingress that is provided by Kubernetes can consist of a few types. The one is actually exactly as you would do it with VMs or on-premise with an actual Nginx instance. And the other is that we can also plug in cloud infrastructure again, such as Amazon's application load balancer. This allows you to leverage the capabilities that Amazon already built in their application load balancer without having to roll out it yourself. What I have not covered in this webinar about the objects are stateful things. There are ways where you can mount the external disks, and there are ways where you can easily run stateful full applications on top of Kubernetes. This is a bit tricky to explain, so that's something for a more advanced webinar. Also, I have not touched at all how you can have isolation and access and resource restrictions between different, let's say, teams within your company. Some things that are useful for that are namespaces and network policies to make sure that specific applications can or cannot talk to each other, role-based access control for all of those API endpoints that are used internally, and limits on how much memory a specific application can use. And there are many more that I'm not even going to cover. So to summarize, what I've just been teaching you are the core concepts and architecture of Kubernetes and its most important objects. And this is enough to be dangerous to start reading the Kubernetes documentation and blogs and really get the most value out of that. Before we're going to wrap up this webinar, I would like to share a few practical tips to get started with experimenting. And my main tip is to install Minikube. Minikube is a project, as you can see, based on its GitHub address that is actually managed by the Kubernetes project itself. And how it fits in the architecture is that it allows you to run the whole Kubernetes system on one laptop. And that's also why it actually is going to model just one node, because it's a small virtual machine that contains both the control plane, the API service, the controllers, and the etcd database, but also the parts that run on your worker nodes. So once you have installed Minikube, you can start it, and then it will download some images and start the virtual machine. And once it's done, it will say that it is configured and ready to use. Just to be sure to check that it is working properly, you can run the Minikube status command. Now let's do something interesting. I've been talking a bit about the deployments and services and pods, etc. And using kubectl, as I said before, we can either apply manifests, upload manifests to Kubernetes, but there are a few shortcuts here and there. And one of them is the kubectl run command. This command will create a deployment called hello. and expose it via the node port option on port 80. Port 80 on the container that I'm specifying later on. And with the image option, I'm specifying a specific container image that I would like to run in this deployment. And if I run this command, it will just tell me that it has been created. Then I would really like to expose this, this application on the outside of my Minikube so that I can get access to it from my web browser. And once I've done this, I can indeed request Minikube to give me the address for this specific service that we have exposed. And if you visit this address, you will see a small page. And as you can see, it says this page is served by hello-something-x98b. And that's the host name of the what the program thinks of the host where it is running. But actually, it's the name of the pod that is running, the container name. And if we take a look at the following command, it will list all the pods that are available in Kubernetes at this moment. And because we're not running any other workloads, we'll just get back the one that we just saw that ends with x298b. The same we can do for deployments to get some more information about that. So in this command, we get all the deployments that are currently on this Kubernetes cluster. But if you specify the name after it, you'll just get this, just the one. And this is a bit silly in this case because we have only one, but I'm getting somewhere. That's because I want to show you the output, the YAML output of this specific deployment. This YAML file is the manifest that I've been talking about for a while now. The output is a bit intimidating, so I've applied some coloring to make it a bit easier to see. In the output, we see 3 parts. The metadata, which is in pink, the specification of this manifest, and at the last part, the status, which is in green. And I've elided some options because they're too long to put in this slide and they don't really add any value. Sorry. So let's take a look at this specific rolling update type that is mentioned here. And I would like to know what it actually means in this manifest. That's my last tip that I want to share. You can use the kubectl explain command. And if you run it on the deployment, that's the object type that is defined in Kubernetes. It will actually talk to the API service of Kubernetes and extract the information from that live server. And you see here that indeed all the top level fields that were in my YAML file are also described here. But we're mainly interested in the specification. And yeah, the description is explanatory. It specifies the desired behavior of the deployment. So if we put .spec after it, it will go one level deeper and show that indeed it has some more subfields. But we're just interested in the strategy, the deployment strategy. So we add .strategy at the end, and then we will get the description of the different types of strategies that are supported. And we specified the rolling update in our manifest that I showed before. So let's take a look at the specific settings you can set for this rolling update. That's a whole bunch of text, but it has 2 fields, the max search and the max unavailable. And in the text, it says that by default, a value of 1 is used. And that also explains why those values are set by the API server. So when I did the kubectl run command, it created a default deployment, and it filled in some default values that I did not specify on the command line. Some of them being the update strategy, which is the rolling update strategy, and also that it is allowed to search by 1. And it is only allowed to have 1 to be unavailable. This is all I wanted to share with you today. So for next steps, I would really recommend you to take a look at our website. We have lots of blogs on all levels of knowledge about Kubernetes. Another very good resource is the reference manual. So if you go to kubernetes.io and check on manual or documentation, you will get very detailed information. But based on the information that I've been giving you in this webinar, you should be able to just click through and find what you want to know. And if you want to be a bit more hands-on, you can always contact us to follow a training. I'm now going to check if there are any questions that have been posted.
So we do have a question regarding Minikube. Does Minikube act like an API server on your local machine?
So definitely yes. Sorry. Indeed, Minikube runs all the components.
Yeah, Martin's having a little bit of a coughing fit. So if you could just bear with us while he takes a sip of water. So the question is about Minikube acting like an API server on your local machine. For those of you who want to ask additional questions, just please do so in the questions tab of the GoToWebinar panel. Okay, Martin, are you back?
I'm back, yes. Sort of. Yeah, so Jamie answered the question. On Minikube, you basically run all the components that you run in a production cluster, except that it's a bit scaled down. So in a high available setup, you would run multiple instances of etcd to have a high available database, and the same is true for the API server. But on Minikube, you would run only one instance of those.
Okay, good. I think there are no more questions. So we would like to take a moment to thank everybody for attending today's webinar. Please do sign up for Ian's webinar, which is in a week from now. And if we can help you at KubeCon or with anything else, drop us a line, and have wonderful Thursdays wherever you may be. And that's goodbye from me, Jamie, and it's goodbye from him.
Thank you for listening and watching, and have a nice day.
Okay, see you later.